Hey, good morning, all. Thanks for joining. This is Swami. Let me share my screen real quick and we'll start the session. I am sharing my screen. Okay, let me give some quick introduction before we start. So this is the meetup where I'll publish all the events. And today's event is JIT compilation and creating console apps using .NET 6, 7, and 8, basic types and a little bit of conversions. And this is the Meetup Group's YouTube channel, .NET Learners House YouTube channel. So please subscribe to this, and uh, also you can join this. And let me give the GitHub URL. This is my GitHub URL where you can go and find all the code. So I'll post it here just in case if anyone wants to access that. And today's code will be here. For this microservices series, I exclusively created a organization where all these repositories will be there. So particularly today's session is here under this documentation. This is fourth episode out of 120 episodes which we are planning, a minimum 120 episodes. So it could be more, I don't know, but this is what the initial plan. And one more important point is this event, whatever I'm conducting, these are coming from Microsoft's Learn community. You can see this MSFT community. This is the Learn group. There are quite a few Learn experts in this Learn community, and I'm one among them. And each one of us will have a exclusive tenant. So from where we can conduct all these events, and you can see currently I have 600 plus members in this channel. So I'll be publishing this here, but net I'll be publishing here as well as on my meetup group. So please join both the learning room. You can join this learning room so you can you'll get notified whatever I'm creating this events, and similarly here and my YouTube channel. Okay, that being said, let's start with today's session. There are a lot of things to cover. So I am a lifelong learner, and you can see that. Please fasten your seatbelt. There are a lot of things we have to cover. First, let me walk you through real quick on what is that I'm doing it now. A1. So what is that I'm going to do today? So here in this previous episode, we have seen the source code, the compiler, Roslyn compiler, and intermediate language. Now this session, we will do a deep dive into the JIT compilation process and see some of the machine code, even though that is how the process happens. We'll go and see that whether when the method is getting JIT compiled, when the method will not be JIT compiled, and we'll learn deep into that. We'll see that. And the next thing is we'll speak about the namespace and importing the namespace. First, I'll speak this point 2 and then come back to point 1 uh, uh, because this is something which I want to speak, and or else we can directly go to first point itself. So creating the console application in .NET 6 using this frameworks, and then we will be creating using the global.json inside the folder. We'll see that is another method to do it. And then we'll see one example of primitive or basic data types and constants. So we'll see that there's one demo. And the final demo is implicit typed variables and also regions in the code. We'll see that. Okay. So there are a lot of things we have on our plate to chew. So let's start discussing on this one. So we saw that the source code is the one which we write it here. So let's take the same example, whatever we were dealing here. So this is the source code. Everything is the source code here. And then Roslyn compiler will transform the source code into intermediate language. So when we do .NET build, so that's when, you know, the Roslyn compiler will kick in and I do .NET build. So the compilation process will happen. Roslyn compiler will kick in and take the source code and compile that into assembly, okay, into an intermediate language. Technically, it's called as an assembly. Typically, it could be a DLL or an executable. So that also we probed it in the previous episode, but let's do it for a benefit. We'll do it now also. So I'm here, so I can come back to this one and I do an IL disassembler, and I can come and pick up this, and you can see the everything we are seeing here. And we know that it is bringing in the content from math service VB library and also math service C# library. You can see that that's the VB.NET library. And still, if we go a little bit deeper, we should find the C# libraries integration. Here, the CS library, you can see that the integration is happening. And also we will be able to see that the main method, you can see this, the main method is something like this, main $. So we have seen that this process also. So we've seen source code, we have seen the compiler, we have seen the IL code. This is the intermediate language code. So now the next step is the JIT compiler. How does the JIT compiler happens? We'll see that. Okay. Before that, let's read through this one line. So intermediate code statements closely resembles the assembly language. Okay. So the .NET's virtual machine, previously it used to be called CLR. Now it's called core CLR. So what this core CLR does is it does the just-in-time compilation. There is a ahead of the time compilation also that we will be discussing in future, but at least for the next 6+ episodes, we'll be sticking to the console application and learning the building blocks. And then we'll start with HTML, JavaScript, and EF core, minimal API. Then we'll start it. This is just a foundational blocks which I want to start with. Okay. So there is a two-step compilation process. The first step is the source code to IL, and the second step is from IL to machine-specific instructions. Right. So we can use some kind of disassembler tool. We have already seen the disassembler. Okay. Now let's see the JIT compilation process. This is something which I have learned it from Mr. Mike's Pluralsight course. He is a wealth of knowledge. So whatever the demo I'm showcasing about the JIT compilation process, it goes to Mike's course from where I have learned that. Okay. So thanks, Mike, for the course. Let's come back here. So we know that, let's again quickly see this, what is happening. So here we have C# library and VB.NET library. So the code in which these two libraries exist are different, and also they belong to different programming language, and also the types also named as differently. If you see, it is called integer, here it called int. And also we went into the common type system where we have seen, at least at a 30,000 foot view, we saw that what is common type system and what is common language specification. Just we did a quick glance. And here we can see that the console application, which is integrating with this C# and VB.NET library, is in C#. So how is the C# code able to consume two libraries, which is in C# as well as in VB.NET? That is possible because of the common language CTS and CLS, common type system and common language specification. That was the proof which we have seen here. Now let's probe into the JIT compilation. Okay, first I'll execute this program and then we will see the JIT compilation process. I do .NET run -- project and I do program structure v3, program structure v3. So once we execute this code, it executes some of the thing. Now I put a debugger to go and do a little bit of probing. I just learned just enough this debugging skills to showcase this demo, but that clearly shows what is happening under the hoods. Okay, so anyways, I'll execute it and I'll tell that what is that which is happening and where did I place the debuggers okay, to watch. So the first debugger, when it comes to the two-phase compilation. So JIT compilation, what it happens is, let's see this method. There are three methods. One is the starting method. Let's exclude this from the game. Let's think about the instance methods. So when the instance methods are there, we are consuming this math.cs inside our program.cs. So when the JIT compilation loads this, it compiles this program because this is the starting point. So it compiles this. And here, if you take this sample, the VB.NET library, the moment it hits here in this line number 25, that is when the JIT compilation understands that, hey, I need to go and compile this method. Only at that time it goes and compiles the add numbers method. And before that, that method will not be JIT compiled. So that is what we are seeing this in the documentation over here. You can see this when the first debugger hits, when we go and search and ask for, hey, did you compile the add numbers? It says that it's not a JIT compile. Once we come out of this block and then you go and ask the same question, hey, did you compile this add methods? Yes, because we have called it. So only at that time it compiles. Now there is another method called multiply numbers. Even after coming out of this block, if you go and ask, did you compile this multiply numbers? It says that no, I didn't JIT compile. That means it is not even spending a second or a millisecond or a nanosecond. It is never ever spending any time on the method which is not compiled. That means technically, if a library you're consuming has got 1,000 methods, and out of 1,000 methods you're consuming only 2 methods, and 998 methods you're not consuming, so the JIT compilation will not spend any time on those 998 methods. It compiles this 2 methods just before you calling it. Just before you calling it, it compiles, and then next time again you call it, it will not spend any time because it already JIT compiled it. So it is very, very efficient compilation process. Okay, let's see that in action now. Okay, we have Abdul was joining us. Okay, we have Abdul and Ivan. Abdul, you're on right time. We are doing the JIT compilation debugging. So first thing what I will do is I will go to file in this WinDBG and I will launch an executable, that is program structure v3 demo. So when you see that the program structure v3 demo, so we will see all these things over here. So first thing what I'm doing is I will execute that G, or technically I can click on go here. Okay, so we are seeing it comes and it loads quite a few libraries. We are seeing that all these libraries from Win32 as well as Microsoft App Repository, a lot of these things are getting loaded, and I'll click on Go. Then we can see that it is coming and loading the core library. You can see this core library, CLR, JIT, and system runtime, core CLR, host policy. A lot of these .NET libraries, as well as the library which we are using. See this, the math service VB library, math service C# library, and also it has loaded our program structure, this one also. And here you can see once it loads, it is stopping here. Okay, I will minimize this so that we can reduce the size of this so we can see both these processes. So I just type the name because I'm asking. So this is watch the CLR's JIT compilation magic. So that means this is the first debugging point just before we are consuming the VB.NET library. Okay, so what happens is at this point of time, we can come back here. There is one of the this tool, the debugging tool is created by the same team who develops the core CLR. They'll give this tool SOS where we can go and debug. So here there are a lot of commands and you can find about each and every command. So see, this SOS is a debugger extension, DLL, designed to aid debugging of managed programs. So this uses, we are using the SOS to get deep into the weeds. So a couple of things we will focus here is one thing I want to focus on the EE version. Let's see those things, and then specifically for us to understand that, one thing is EE version, which gives the version of the .NET. Let's go and type this EE version. So it says that it is .NET 8. And that's the workstation mode. It gives the SOS version as well as the .NET 8 version. Now, the next thing what we can do is, if we want, another thing is name to EE. So if you come and type name to EE, so what is that it asks is, it asks is the module name and the item name. So what we can try is to go and search for this. Is let me search like this. So looks like it searched this one. The module is this one. So we can search. Now let's come back and dig into our methods. So the debugger right now is here in this line number 22. That means line number 25 is the first instance where we are calling the add numbers. Now let's go and try. We'll ask, hey, did you compile this? So here it says that, hey, I did not compile. See, this not at JIT compile. Okay, it says that this from the math lib, from the math add numbers, this has been not yet compiled. So method description is here. We can go and check the method description also to find out few other information, but mostly we will see that. So here it says that it is not yet JIT compile because the machine instruction is not yet ready there. So what we will do is we will hit and I'll click on go again. Okay, now it is running and it compiled. It compiled it and we are stopping at the next debugging where we wrote the read line. That means it executed, see this math.vb.net. It says that math.vb.net library. So it executed this command. That means technically the JIT would have spent some time and it compiled it. Now, never again we need to compile it. And this is the second one, which is that here. So now if we go back to the Win debugger and break here And now let's execute the same two commands. So this is the add numbers. And here it says that previously it said that it's not a JIT compile, not a JIT compile. Now it says that, hey, yes, I have JIT compiled it. Now, if I come in here and see the method description, now it is giving the machine code of that. So we can still dig deeper. You can see this, the VB.NET code, but see, this is the machine language. Now let's see whether it spent some time on JIT compiling the multiply numbers. We didn't call multiply numbers anywhere in our code. So if I come back to this one and do the multiply numbers, I need to break it here and search for this. It says that it didn't JIT compile. So that should be fine. So now I press enter and come back and click on go. And again, it is running. So now the second debugging, which I kept it here, is this one. We completed working with the VB.NET library. So now again, still I'll come back and I'll say that, did you compile the VB.NET's multiply method? It says that, no, I didn't compile. So now let's come and see that add numbers. And if you see that add numbers, it didn't compile because that is, I placed the read line just before invoking that method here. In line number 44, I placed the read line, but in line number 46 is where we are calling the C# one. So what I will do is I'll come back here and I'll say go. Now that means if we see that it passed through and it completed that invoking the method. Now currently the debugger is right now here in the second read statement here. See this WinDBG, the second statement. Right now it is at here. So now what I'll do is I'll again come back and do a break and try to look at this one. Now it says that, hey, it has debugged. Just the method description. And press U and put this. Now you can see that the method description it shows. And I will see if it compile. It says that we didn't compile the multiply numbers, but it compiled the add numbers. Abdul, could you please go on mute? Okay, so that's the thing. And JIT coded address also. Suppose if we come back to add numbers, so this is the JIT coded address. We can come back and we can do exclamation U in this one when we will see. And also if I come back to add numbers, the method description also we can copy and come back and use /-u, and we can see this one. So now I'll come back here. That is where we are stopping, and come and click on go again. Now debugger is running. This is press any key to exit. So that means we have come back to this line, press any key, line number 62. So technically, now we'll come back here for one final time. And we know that those methods are already been compiled, but let's see all these things step by step again. Add numbers from VB.NET library, we used it. That was JIT compiled. Then multiply numbers from VB.NET library, we did not use it. So it didn't spend even some seconds or nanoseconds or milliseconds, whatever is the least. It didn't even bother to go ahead and look at that method because we didn't consume it. Now in the C# library also, we saw that we consume add numbers, so it just compiled that add numbers. When it comes to the multiply numbers, it didn't even spend any time to git compile that. We are at the end of the program. Okay, now I clicked on that and click on go, and you can see that we are done and dusted. We are out of this. So what do we understand here is, let's come back to the picture and we will see one final time. It's like a quick refresher. So here is a source code. We saw that the source code can be in any of the .NET compliant language. Everyone should stick to the game plan. Like they need to use the common type system and common language specification. These are the rules of the game. Any .NET compliant language should stick to that. Okay, so that's about the source code. The second step is Roslyn compiler. So this compiler will transform the source code into intermediate language. So intermediate language looks pretty similar to the machine language, but you can see this this side of the world. You can see almost some of these words we would have encountered here. See this move, add, pop here. These side, it looks pretty similar to those actions here. See move, NOP. Yeah, you got the NOP, and a lot of these things are pretty similar words, which I'm seeing add and those kind of things. It's almost similar to that. And we saw this. And today we did a deep dive understanding the JIT compilation. So JIT compilation is very efficient. And we seen that we are consuming two libraries, one in C#, one in Visual Basic. Both has got two instance methods, but we are consuming only one instance method from both C# as well as VB.NET libraries. So JIT compilation, just before invoking that method, it goes and it compiles it, and never ever it need to spend any other time on compiling those methods. And one more key thing what we found is, if we are not consuming the method, it will not even worry to go ahead and spend any time on compiling that. That means an hypothetical example is, suppose if we have 1,000 methods, and of the 1,000 methods, you are consuming only 2 methods, the JIT compilation will spend time just before you invoke that method. It will go and spend time on compiling those 2 methods, right, to the machine specific instructions, and it will ignore the 998 methods. So that means it is intelligent and efficient. It compiles only what is needed and on demand basis. It don't go and start compiling all the methods. Whatever is necessary, it will compile that. Okay, so that was a deep dive into that. Abdul or Ivan, do you guys have any queries on this piece? If you have, please do let me know. We can discuss, else I will move to the next topics. Okay, let's go to the next topic. Is that this one? So namespace and importing the namespace. This is very important topic when it comes to, I mean, anywhere it is important. When it comes to the .NET 8, it's all started from .NET 6, 7, and 8. A lot of the improvements has started. So I will give you the crux of these pieces. It's very key and important. Let's see one by one. Let me close all of these things and come back to the first session, where we'll see in this traditional program structure. The traditional program structure, if you see that, the namespace, first thing is you'll wrap everything inside a namespace, and you'll have 2 mustaches, and you have class, and again 2 mustaches, and you have the main method and the 2 mustaches, and the block. I mean the namespace with a block. So this is block scoped namespace. And in recent days, and if you see that, when this is like traditional, it's a block scoped namespace. So namespace and you'll have block is the mustache brackets. And if you see, this is called file scope namespace. I mean, there's nothing difference in both, but the only thing is how you are using it, whether it is block or whether it is file scope. So in recent days, it's good. I mean, anyway, whatever best works for you, you can use it. But I started using the file scoped namespace. So that's the first topic, block scoped or file scoped namespace. And using namespace, using import features. So that means if I have to use that namespace, that means this math library, I need to use the namespace. So I should specify the using. And here also I should specify using. Suppose I'm using time and task and reflections. So there'll be a bunch of usings over here. So what .NET team they did is they intelligently went through, and for each of the template, maybe you're using the console application or the Windows application, web application, or whatever the type of application templates they have created one intelligent thing called global using. So that's what we will be seeing. Next thing, this is imports. We have seen that if we want to consume any of the class and methods, we need to use the using statements in that particular class. If not, it will not work. So two important pieces to understand is here, if we go to the program structure, implicit usings, here it is enabled. In this V1 project, I have disabled. That means if you go to the here, wherever it is enabled, in the version 2, we enabled it. We'll go to the OBJ and debug. So here you will find a file called the project name dot global usings. So if you see that the project name is this one, program structure demo v2, program structure demo v2, the project name dot global usings dot g dot cs. So here, these are all the imports which we are getting it implicitly. We are not writing using statement anywhere in our code, but still we are enjoying the benefits. You can see that here we are just using the services, but in this program CS, we have to use the system because we are using this console, these things. And here in this program, we are not using the system. Why? Because of the global usings. So where we have enabled in the program, in the project.cs proj, we said that implicit usings is enabled. So whenever you enable the implicit usings, so you will get the benefit, like based on this templates, these are the things which it will be imported by default. So you don't need to write the using on the top in the project. Only those libraries. Suppose you're using any other libraries, definitely we have to go and import that. Like if you see that I didn't write using statements in the in this program.cs because it is system using system is getting imported by implicit usings or the global using. That is very important point. So we understood 4 points here. One is the block scope and the file scope namespace, and to consume any methods or class or methods or whatever the artifacts which you want to consume from any library, you need to write the using statement at the top. Now, in recent times, what was there is .NET started giving a flexibility identified based on the type of the project. They started adding the implicit usings also. So that means when you enable that, again, they are giving you a flexibility in your CS project. Do you want to use the implicit usings? We'll give you a set of usings by default. If you don't want to use it, then you need to again go and specify usings see this here. If we come back to the OBJ, you are getting benefit of 7 namespaces which are automatically implicitly getting used, implicit usings. You are using it. If you are using any of the artifacts or the members of these libraries, you don't need to worry to type using at the top of the class because it's getting implicitly used. Okay, so that's the another benefit. So next important point which I want to cover is, let's see the notes. I'll minimize this. And usings we have seen global. One is implicit using. So this is very beautiful thing. I recently started using it. Now, if you come and see that in the program.cs, I'm not writing this console.console.console. Here I'm writing the console dot in all these samples, but in these 2 samples, I'm not writing the console dot because see this here, if it is 21 to 27, 7 lines. Here, if it is 7 lines and foreground color 7, 7, 14, 15, 16, 17, around 17 lines, I don't need to write console dot, console dot, console dot. So how is that possible? It is possible because of the implicit using. Here, if you see the documentation, that is implicit importing the namespace. So here we are writing it. And also I said that static is true. Not only the namespace I'm including here, also I'm saying that console library. Okay, I'm saying that use static. So other way to do the same thing is we can come back here and we can say that using static system.console. This also we can do, or else we can do it this way. So doing this way is what? If you have to use this particular console in 10 different files, you don't need to go and write using static system.console, using static system.console in all those 10 different files. So putting this into your CS proj makes more sense. When you want to use the static import, you have to better use it here in the C# proj. Okay, so we have covered a lot of ground, even though the concept is very simple, but there are a lot of advantage in that. You can see that here a program, it has got 20 plus lines, 7, 7, 14, almost 20 lines, where I don't need to write the console dot. Okay, less type, more energy. Okay, jokes apart, but seriously, we learned about what is block scope and file scope namespace. What is using statements at the top of the file, and what is global importing namespace. That means when you enable that in your CS proj, the project or the framework will create the project name dot global usings.g.cs, where it imports based on the project template which we create, and also implicit importing, where we can go ahead and write it into our CS proj. What is the library which we want to import? On top of that, the 5th point I forgot to write it was the static import. That means namespace.class. So if there is a class and you are invoking a static method like console.writeLine, so writeLine is a static method from console class. So what you can say that using system.console and implicit, you can static, you can make it true. So like in this case where we went ahead and we told use this implicit using, and also static is true. So the static is true will come when you're using a static class, like using static system.console. So that means system is a namespace, console is a class. So the advantage of going to the 5th step is if you're using this console.writeLine in 10 different classes in your console application, you don't need to mention that in every file at the top of the file, specifying using static system.console in all 10 files. all you have to do is write it here in the CS proj once and use it in rest of the places. Okay, so that's about, we covered two major topics. One was the deep dive, understanding the JIT compilation process, and we visually saw that the JIT compilation is spending time only just before you invoke the method, else it will not spend any time on compiling the intermediate language to machine specific instructions. We at a high level, we saw that how the machine level instruction looks. And also if you have a large library, you're importing it. It has got hundreds of methods and you're using only one method. So you don't need to worry. The Roslyn compiler is pretty intelligent. Sorry, the JIT compiler is pretty intelligent. It will ignore all the hundreds of methods and it will compile, or it will spend time in compiling only the method which you are consuming. And here we spoke about namespace and importing the block scope and file scope namespace and using imports at the top and global usings and implicitly importing in the CS proj. And on top of that, the fifth topic we spoke about was static, using static system.console. So if you're using any of the static methods inside the console class, you don't need to write console.foreground or console.resetColor or console.readLine or console.WriteLine. You don't need to do any of those console dots. All you need to specify is static equal to true. So those were the 5 different things which we have covered today. So let me come back here. Ivan or Abdul, do you have any queries? You can speak, or I'll go to the next topic. Just give me a minute. I'll have a glass of water. Okay. So here, creating console applications. When you have multiple just give me a minute. List is the case. When you have multiple versions of the .NET. So what happens is when you're creating any of this .NET projects, the highest number will win. That means the latest is .NET 8 release candidate 1. So you type any of this command, it assumes that you want to create it using the biggest one. So I'll say that .NET new console --help. Let's see this and understand. So if I want to create .NET new console application, what all the options do we have? So we can specify the name or the output directory. I'll come back to this, please. And dry run, which we have seen that, which is pretty similar to the Angular dry run. And I liked it the moment I saw this command in .NET. It was like a tears of joy kind of thing for me. Wow, now we have it in .NET also. Now, the key thing for this particular section, what we are focusing is the template. If you see that one of the option when we are creating the console app or anything, we can specify, even though if you see, we have 3 versions of the .NET and the default it assumes is .NET 8 because he's the biggest man on the table, .NET 8. So that's the default. So if you want to override, what we can specify is -f equal to .NET 6 or .NET 7 or .NET 8. So we have to specify the framework version. So what is that framework version which we want to go ahead and consume? So in that case, what will happen is it will go ahead and take that. Okay. And ahead of the time of compilation, we'll discuss, we'll wait. Now today we learned about the JIT compilation, we'll come back. Now, another thing I want to show is list. We spoke about the framework. It takes the biggest man on the table, .NET 8. Now, when you go and look at the list, what is that we find here under the language. If you see here, somewhere I saw the language here, the language. We can override the language also. By default, all the templates are C# by default. And it specifies whether it supports F# or VB.NET or both. What is that it supports? So those are not by default. So if you want to override that apart from the framework, we can go ahead and override that also. So that is one important point. Now let's come back to the documentation and we'll see that here. So here I've given all the commands. We can go ahead and execute, and better I'll close that and I'll execute it. So that, you know, cd dot dot, I'll come back here and I'll see there are 4 directories: mkdir, s4, sv4, okay, cd sv4. I came back here. Let's assume, let's follow the documentation and see that. So first thing what we will do is we'll create we'll open in the code. In the VS Code, we have here .NET New SLN, name sv4. So once we execute, let me close these things so we'll get some extra space. And I need to deal with less number of windows. Now, if you see that sv4, it has created a solution. So now let's go and execute this command one by one. Now, what I'm telling is just create a project. Okay. What I'll do is I'll rename this project into S4 because I don't need to modify the other commands, because other commands by default. So if you come and see, the framework version is .NET 6. Let's ignore the program at this point of time. We are learning the technology and the commands. So I will specify, go ahead and add this to the project. You can see that it goes and adds the latest project into the solution. So you can come here and watch. It will add this .NET 6 into the solution. Now I'll go ahead and execute this project right from here. It goes and executes. Looks like my machine is a little slow. Okay, that's cool. Now let's go to the next one. Here I'm creating another project, this one using .NET 7. I'm explicitly overriding this. So we can come back here and get into this and see the framework version is .NET 7. Let me come back to this one and execute, add this to the solution. And now I go and execute this .NET 7 project. It executes the .NET 7 project. And now come back here. And we don't need to specify this, but I just wrote it there because as we discussed, the biggest guy on the table wins. So by default, we saw that in the help also. By default, it consumes .NET 8 because that's the biggest guy. So if it is 9 comes, so then 9 wins, right? So it's always, the world is like that. So we saw that list SDKs. So when will this come into the picture is when you have multiple things. Let's assume there is a folder. At a folder level, you want all the projects to be of .NET 6, even though you have a .NET 8. So you'll write a global JSON file and drop it here on the parent folder where you want all the projects to be in .NET 6. And inside some couple of folders, you want .NET 7 projects, maybe as a proof of concept, they are working on the latest technology. So inside those two folders, you'll drop the config file for .NET 7. And in one specific folder, you want 8. So you'll drop 8. But the parent folder is .NET 6. So in those kind of scenarios, you will need that. So what we will do is we'll go ahead and create, we'll see this. Again, mkdir, I go ahead and create this project. And then what we will do is we will change into that directory, cd NET6 v1. And after changing into that, we will create this config file, because before creating the config file, you need to have this up and running, because 6.0414 matches with the number over here. So that means if you come and see here, you're seeing a new folder, and inside the new folder, you have global JSON, and it says that, hey, whatever the projects you're going to create, consider 6.0 as your framework. Don't consider 7 or 8. So that is what we are specifying in that particular line. And now here inside the folder, if I execute .NET console, I don't need to specify output folder. When you execute inside a particular folder, .NET new, so it takes the folder name and it creates the CS project. Now, if you come back and look at the code, compare with this one, you see .NET 6 demo app where we specified -o, the output folder. So it created the folder and project. But when you execute this command inside the folder and you don't specify any output folder name, it considers the current folder and it creates a project. You come and see that it is .NET 6 and this is .NET 7. Okay, so that is one thing. And let me do cd ... and I'll execute this. And similarly, execute this. Perfect. So now we'll do the same for .NET 7. mkdir and cd net 7. And I'll specify to create a global JSON. And I'll say .NET console. I'm not giving any output folder. I do cd ... Let me clear the screen and add this to the solution and go ahead and run. Now we are dealing with multiple projects. So almost 5 or 6 projects are there inside this. And if I do a .NET build, so in that solution, all these 5 projects has been included. So it will go and compile all these things, even if you're using some libraries inside this or from other folders, it will go ahead and compile even those libraries, because everything is part of this. And here it will have links to the other libraries wherever you have specified. Okay, so .NET 8 is again same. The only thing is you need to be a little bit careful on specifying the version number. Okay, and cd net 8. Let me compile. cd net 8 version 1. And then I'll come back to this one and execute it and do a .NET new console. It takes a parent folder name and it creates a project. and cd dot dot, and go ahead and add this project to the solution and execute it. As simple as that. Now, this is another thing which we spoke today. Let's come back and see this demo. This is very interesting. I like it a lot, this one. So let me switch to S4 project, where I already created these things I wanted to show you live. So I just created. Now let's look at the code for a minute. What is that I'm doing here? And then we will see the built-in types. So each of the built-in type, let's come with the variable. We have 4 minutes time. So variable is a named space inside the memory location. So each named location will occupy some space. Thanks. So a variable is a named memory location where we will store something. Variable, so that means the value which you store in that particular space can change over time on demand basis. And if you don't need to change, you can create a constant variable, but still you have to specify what is the data type. So each of the variable, we have to specify the data type. So C# is strongly typed language. So it's not like JavaScript, the dynamic type programming, where you can create a variable, assign a value, and then over a time go and change it to different, like a string to Boolean to date to numerics, and you can play like that. So each has got its own advantage. Nothing is, I mean, my personal feeling is based on our business and the type of project we are working, each has got their own advantages. Nothing is more over other. Okay, it depends what kind of project you're doing. Do you need a flexibility or do you need the static compiling? Okay, so another thing is each of the variable should have a data type, and each data type will have some specific number of bytes it will occupy in memory, whether it is in heap or whether it is in stack. So if you see the integer type, you have a byte as byte. So the minimum value and the maximum value it holds. Okay. And here we will see that these are integers, these are decimals, and this is the char, and this is bool. And these are some of the other types. This is constant, but still you have to specify what is the type which you're going to store there. So this is int, char, string, bool, decimal, and this is double and float. So let's go and execute this particular program. .NET run ---- project, and that is built-in types. You can see that it executes. This gives like byte occupies one byte or 8 bits in memory, and as byte also 1. But the values, this is the signed integer, this is unsigned integer. And short, again, this is signed, and u short, this is unsigned. And again, int 4 bytes, this is signed, and uint is again 4 bytes, this is unsigned. Long 8 bytes, these are the values which we can store, signed, and these are unsigned. Similarly, double 4 bytes, sorry, float 4 bytes, double 8, decimal 16 bytes. And see the number of values. Wow. Okay. I think I might need to have an extra breakfast and a glass of juice to read that big number. So char, it occupies 2 bytes. It's an unique Unicode character. Previously, when I used to code in C, while I was learning back in 1999, it's only 256 characters. So we used to have that A to Z lowercase to uppercase transformation program, very famous program in C, which we used to do. Okay, so then bool, it takes 1 byte. It has got only the flagging like true or false. Okay, that's this program. And the other one I have it is .NET. That's the implicit conversion. Oh, .NET Run project. Sometimes I'm a little overexcited. Okay, now I just wanted to show you the implicit type demo. So that means in the previous program, we specified each and every variable when we were declaring, we specified that the variable and its type. If you see, age is of integer type. You see that on mouse over, gender is character, string, this is Boolean, this is decimal, this is bonus, this is float, and this is constant, but it is double. Now here I said var, so this is implicitly typed. And again, this is strongly typed. It does not mean that it is dynamic type. We said var and we can go and assign anything, because if you mouse over, it clearly says that, hey, it is age one is of integer type. Now gender is character type. This is string. Is manager one is of Boolean. Salary is of decimal. This is of double. And tax is float. So clearly, based on the type which you give it on the right side, it implicitly assumes that what is the data type. Okay, so this is the session 4 of 120 sessions, the microservices. I just want to give some other foundational blocks for the next 6 sessions, and then we can wrap the C# and then start with the HTML, JavaScript, CSS, along with EF core. Then we'll do every session, we will have the mix and match of the technology, so that, we will learn multiple things inside the same episode. But at least for the first 10 sessions, I just want to purely focus on .NET 8, particularly in C#. And then we'll slowly introduce HTML, CSS, JavaScript, Bootstrap or Tailwind CSS, EF Core, Minimal API, Controller API, React, Angular, Vue.js. A lot of other technologies will bring in Redis Cache, Cosmos DB, MongoDB, and RabbitMQ, Service Bus Queues, multi-cloud. That's what is our intention to create this microservices series with multi-cloud technologies. I will be stopping the recording right now, and Abdul or Yvonne, if you guys have any queries, please